So far we have seen the variance and standard deviation. Now there are certain shortcut method also, because when we are actually dealing with the mean and variance, the number may go quite big or large. So let us see the step deviation method, right? So we have to assume a mean which is called as capital A. The scale, we need to reduce it by 1 by h times, and this h is nothing but the width of the class interval. We'll see by example. Let us first come up to the shortcut method, and let this step deviation, you can say it as a new value, that is yi. This is xi minus a by h, or you can say xi is yi h plus a. We'll use it, so please remember this equation. And we also know that x bar, that is the mean, is sigma fi xi by n. Now from 1 and 2, means from these two, let us place it here. We get fi, and this we have replaced xi by a plus h yi. Now let us further multiply these two, and take the constant outside. This is sigma fi, that is sigma fi is nothing but capital N. Okay, that is the total number of values which are present. This is n by n, and this is sigma fi fi by I by capital N. Now this is going to be a, and this is going to be h, and what this is nothing but y bar. Okay, this is y bar. So the variance of the variable x, sigma x square, is given by 1 by n sigma fi xi minus x bar whole square. In this x mean, we'll place this value, and in the place of x we'll place the previous which we have got from here. So from 1 and 3 we'll place this, right? Then simply taking the advantage of this as the sigma y, because this is h square can be taken out, h square by n. This is nothing but h square into variance of variable yi. So sigma x square is equal to h square sigma y square, and sigma x is nothing but h into sigma y. This one and this one, please remember these two. By this we can easily say that sigma x is equal to h by n, capital N, sigma fi yi whole square minus sigma fi yi this whole square, right? So this is the shortcut method. You know, about this, even if you don't understand, no problem, because we are worried about this. This is our actual, you can say, the way we are going to solve the questions. So this is the mean, variance, standard deviation which we have to compute. These are the classes, these are the frequency. What about the midpoint of this class? 30 plus 40 by 2, that is 35, and like this. How about yi? Yi is nothing but xi minus this 65. 65 is what? We have chosen this, say, as a assumed mean, 65. And h is what? The class interval, that is 10. So yi is xi minus 65 by 10. Yi square means this square. Then fi yi. And then fi, then you have to take yi square, fi yi square. Multiply these columns. So you get what? First let us understand. This is sigma fi, this is sigma fi yi, and this is sigma fi yi whole square. The x bar is nothing but assume mean plus sigma fi yi, which was minus 15 by 50 into h is 10. So x bar is 62. How about sigma square? This is h square by n square, n sigma fi yi square. This we have just seen, minus sigma fi yi whole square. This is 50, this is 105, and this is minus 50. So you get 201, and take root of this, because this was variance. Take root of this, you get the standard deviation. How about the analysis of frequency distribution? You have various frequency distribution. Now you want to analyze or study the measure of dispersion. And see, whenever you have things different, you can understand it very well. But how about, say for example, you have the mean, similar mean. then how can you say that this is better, this is not better, or this is more scattered, this is more coherent? For that we'll use the coefficient of variation COV, and in this coefficient of variation of CV, this is sigma by x mean into 100, and in this, when we compare the variability or the dispersion of two series, COV we will compute, and the values CV, if it is having the CV value is more, we say it is more variable, otherwise we say it is more consistent. How to compare these two frequency distribution? Let x1 bar, x2 bar, these are the means of these two different distribution. Sigma 1, sigma 2, these are what? These are the say the standard deviation, sigma 1, sigma 2, and CV is given by sigma 1 by x1 into 100, sigma 2 by x2 into 100, and we are talking that x1 and x2, these are x1 bar and x2 bar, they are similar. So this is first distribution, this is second distribution, these are equal. It now became very prominent or perceptive that sigma 1 and sigma 2 are going to decide. We'll see this with an example. Let us take an example first, then you will understand better. So we have two plants A and B of a factory, and we need to see these are the result about the number of workers and the wages being paid to them. Average monthly wages are paid, and this is the variance. See, this is the x bar and this is y bar, for example, or this you can say x1 bar or x2 bar. These are equal. Now the question being asked is, in which plant A or B is there greater variability in individual wages? So the variance, the first one, sigma 1 square is 81. What is the standard deviation? Take root of this 81, that is 9. How about this sigma 2 square? Take root of this. So now the standard deviation is 10. We see in 9 and 10 which is bigger? 10 is bigger. So this one, because the average monthly wages are same, 2500. That is why the plant with greater standard deviation, that is this, has more variability. So plant B has greater variability. How about this example 14, COV, that is CV, coefficient of variation of two distribution are 60 and 70, and their deviations are 21 and 16. So this is CV, this is sigma 1, this is CV of second distribution, this is sigma 2. Take the formula x1 bar and x2 bar. This is sigma 1 by x1 bar into 100. The second one is this, you just place the value, you get x1 bar. This is 35. How about the x2? x2 you get 22.85. This is how you get the value of x1 bar and x2 bar using this expression. Now next is these are the values which are calculated in respect of heights and weights of students of a section of class 11. So this is the mean and variance of height, mean of height, mean of weight, and variance of height, variance of weight. So can we say that the weight show greater variation than the height? So if you want to compare the variability, we need to compute the CV, coefficient of variation. So variance of height is what? This is given 127. Standard deviation is under root of this. So under root of this is 11.3. Variance of weight is this 23.16. Take root of this. That will give you the standard deviation, which is 4.81. Now CV, coefficient of variation in heights and coefficient in weights. So this is standard deviation by mean, standard deviation by mean. 11.3 by 162.6. Standard deviation by mean, standard deviation by mean into 100. This is 6.95, 9.18. 9.18 is greater than 6.95. So this is greater. So we can say that the weights show more variability than heights. So this was one more session, and we'll be taking the miscellaneous and revision in the next one. Thank you so much.